Today on After Effects Test Drive, we're going to take the latest version of the plugin Newton for a spin and dive deeper as we focus on the joint system. Newton version 3 is a 2D physics engine for After Effects available on aescripts.com, which allows you to apply real-world physics to your objects and animations. If you're a motion designer working in After Effects, chances are you'll find a use for this amazing tool. It's a pretty deep program and there are a lot of parts to it, so in this video we're going to focus on the joint system tools. If you are just starting with Newton, you'll probably want to watch the first video in this series that deals with the core functionality of Newton itself, so hop over to my YouTube channel and watch that one first. In this video we'll work with each of the joints, including the two new joints in version 3, wheel and blob. Let's get started. Newton's joint system can be really powerful once you learn the different joints and how to manipulate them and how to effectively combine your objects together. So I've got a very simple setup here. Let's just hop right into Newton and I'll just introduce a few things to you here. So I've got these three circles here. Actually, I'm going to move this floor object over to here and I'm going to make it static and everything else will be dynamic. So I'm going to select these three objects, and the joint panel system is in the bottom center here, and we have the different joint types available along the top. I'm going to select the first one with these three selected, and this is the distance joint. So it creates a distance joint between 1 and 2 and 2 and 3. Now when we run the simulation, not much is going to change with this particular setup. But what the distance joint does is it maintains this distance all the time. It's a rigid joint system. Now we can get in and change the points of these joints. So in our joint panel, because we have these balls selected, it's showing what joints are being connected with these active objects. So let's select the first joint, which is from 1 to 2. You see it turns red there. Along the top of the preview we have a anchor point tool. We select that. That's how we can manipulate the points of these joints. So if I grab this and drag it to the outside of that object and then the far left edge of this circle and then run the simulation, doesn't look a whole lot different. But let's now take the first ball and change its position. I'm going to move back to the move tool. Change its position. Change its position to, let's say, there. So there you see it now is maintaining the relationship, the distance between these two joints. And it's going to go right off the table. Yeah, there it goes. So it maintains the relationship, the distance relationship between these two objects. Now we can set things up a little differently. Let's select those three balls again. I'm going to select my two joints that are connecting the three balls. Say delete with the trash can there. And let's move this ball back to its original place, and we can do that by selecting that ball, right-clicking, going down to Reset Body Transform, and it pops back into where it originally is from the timeline. Now, if we select the three balls again, actually what I'll do is I'll select the first one, the third one, and then the second one. And then select the distance joints. And you see it's set up differently. If I move the center ball down, you can see we are now jointing 1 to 3 and 3 to 2. It's a different relationship now. And if I wanted, I could select number 2 and number 1 and make a joint between those two. And now we have a closed loop joint system. When we run the simulation, we get that sort of effect. And it's a rigid distance. It keeps the distance between the two. And it is anchoring itself to the anchor point, which is the center of these objects. Now, let's go back to frame 0 and let's move these joints around. With the anchor tool, let's go to the edge of these objects. I'm just going to move some of these around. Now let's see what that gives us when we run the simulation. Totally different effect. So you can set up some complicated arrangements with the distance tool itself. Okay, so let's work on the vertical joint system here. So if we've got these three balls and we want to connect them by a distance joint, we hit the distance joint, they're connected now. But if we select the top circle here and make it static, so it's not going to drop, it's not going to be affected by gravity. So when we run the simulation, nothing happens. But what if we were to position this ball so that it's slightly off center, up a little bit and off center? Now when we run, it has a tendency to drop down because our gravity is pointing straight down. It will try and move. So now we get an interesting sort of pendulum effect from that. And following with that thought, so let's say that we've got our first ball here is going to move. It's going to pick up and it's going to move. And we want the other two balls to follow. So go into Newton, make our floor static. It is. The first ball, we're going to make it, instead of dynamic, we're going to make it AE-matic. So the animation from the timeline is going to be pulled in to this object. Now let's select these objects together by a distance joint. And let's see what happens. So what's happening is the animation of this ball in the timeline is pulling it across, and because of these distance joints is dragging the distance joints, dragging the other balls with it, maintaining their distance. Now pivot is different. So let's just make our floor static. I'm not sure if we're going to even need the floor. So let's select our letters and create the next one over, which is a pivot joint. And what this does is it does the same thing as distance, but in the center there is a pivot point circled that these objects will be able to rotate around. So in this example, if I was to make the V static, so it's not going to drop, I still have gravity in place here. When I run it, you can see that these letters drop away. Now, by comparison, let's get rid of all of our joints for a second, and let's make them distance joints and run the same thing with the V still being a static. See, they kind of drop like they're on a string. Go back to the pivot. So you can see they clearly rotate on those pivot points. And like any joint system, we can get in and we can adjust. Select this pivot point, move it up, move this one up. Now when we run it, they pivot differently. All right, so they're pivoting around this point. It's like rotating around a different anchor point. Move that down. There you go. So different effects that you can get with the pivot joint. Now the piston joint is different again. So I've just got two shape layers, two squares. So if we go into Newton now, and let's first of all, let's select both our layers, and we'll go over here to the piston joint, and we'll add a piston joint between these two. Let's select that joint system and activate our anchor tool. And you'll see that, I'll zoom in here, you'll see that we do have a controller handle here. I won't move it just yet. We'll see what happens in the relationship between the two. Since I don't have a floor object, I will enable the new feature here, infinite ground, and that will put a floor plane right at the bottom of the comp here so that they can drop to. And let's see what happens when we run the simulation just with the joint at its default. So there's a bit of a pull in. There is It's like there's tension between these two. And that can be maybe even a little more evident. Let's say that I keep gravity the way it is, but I change this square, the aqua square, to static so it won't drop. So we'll see what happens now. See, there is a slight pull of gravity, but the strength of this piston joint attracting it to the parent is stronger. In the piston joint itself, with it being activated, and you go to the joint properties, we do have a motor available on this joint. So if we enable that, and then we turn up the torque, say 30, and turn up the speed, and then run it. Let's turn the speed up quite a bit. We're going to start getting more of a pull. So if I turn that off, there's not as much energy. I turn it on, there's more of a force pulling this square. Now we can play around with things here. Go back to the first frame and enact our anchor tool. And if we rotate this in different directions, we're going to get different results. See, the pull of the motor, of the piston motor, is now pulling it in this direction. What happens if we pull it up? Now it's fighting gravity, but it's also being pulled in the direction that piston wants it to go. So you can see you can have a complicated relationship, particularly when you start tying other objects to this child object. And if we take the gravity down to 0, and let's turn it up the way we had it before, it's going to pull it in that direction, and there is no gravity to try and fight with it. So you also notice that with the piston joint, there is no rotation of either of these bodies, particularly the child. It maintains its rotation relative to the parent body. So let's duck out of this. I'm going to create some animation keyframes for the parent. So I want to do a rotation. So we'll just go here, and we'll just go ahead a couple seconds and just do a rotation. So we'll go back into Newton. And I'm going to take the parent shape layer, I'm going to change it to be kinematic. Now when we run the simulation, and let me just see, I still have my joint system in place, the gravity's still at 0. So there you can see that the rotation between the two bodies is being translated. You can also see that the rotation was only about a couple seconds long, but the rotation continues because gravity takes over that inertia of that initial rotation. And if we were to have, let's just see what it looked like with the default gravity. And it'll drop because the animation will have stopped at that point, and Newton gravity will take over. If we changed this body to being aematic, it's going to be using the animation from the timeline, but there'll also be a pull of gravity upon it. And as we saw earlier, we can adjust the tension that the gravity has on this body. Now the spring joint, like you can guess, is a spring between two objects. In this example, I have the letters spring being connected to the floor object with spring joints. So when gravity takes over, you can see there is some tension with each of the springs. It tries to maintain its distance as much as it can, but then it collapses upon itself because the springs themselves are not strong enough. Now we can adjust the strength of the springs. Let's select all of these spring joints. We can adjust the springiness. So now they really have a major effect on their springiness. It's a lot more rigid. Default this back. Let's go to, say, 0.3. And there you go. Totally different effect. But there's also a desired length. And we can adjust the length of the tension of the spring. So that has very little effect, or we can really extend it out. So now they spring up. Now we can select our box here, and then select the floor, and select a spring joint. And you see you can't see it immediately. So let's select it here. And it's this red dot right here. So if we grab that, actually we'll grab it with the anchor tool. And you can see then it stretches out, and then we can grab the other side. Now we have a joint selecting the box to the floor. We need to adjust its parameters. But what if we selected two springs? So let's do the same thing again. Make another spring joint, select that one, and with the anchor tool, bring it over. And then go back to the first one, put it here. Let's make these desired length the same. Let's go 1.7 on both of these so that they're equal on both sides. There you go. Kind of. Okay, so I've got a train system set up here. I have the actual artwork of the trains right here. I will replace them in the final render. So let's shut those off for now. And I just drew some shape layers to match the outlines of my artwork. And I've drawn a rough outline of the edge of the cliff here, because this train is going to drive off the cliff, and it may hit this surface here. So what I've got is I've got the engine, and it's going to move forward. And it's going to pull these cars with it. And we're going to see the different joint relationships. So we're going to make our cliff edge and our track here static. We're going to make the engine itself kinematic so that it can take the animation from the timeline. And then I'm going to select the engine and the cars. And we'll start with the distance joints. Now I'm going to adjust the distance joints. Actually, if we just run it just the way it is right now, you'll see what it looks like. Animatic takes over, and that drops away. That's not bad, but they're not being connected where they'd normally be connected. They're connected at their anchor points, but we can change that. So let's select the first joint, go into our anchor tool, here to here. Next one. There we go. All right. Now when we run it, they're connected normally where they would be connected if they were actual trains. So that gives one kind of effect. But what if we were to change the joints? Let's select all those joints, trash them. Now let's connect them with pivot joints. And we'll do the same thing again. We're going to adjust where they connect. They will always connect to the anchor point, but we change the pivot point where they'll be rotating around. There you go. Okay. So now when we run, bit different of effect. Let's trash those. Just for interest's sake, let's see what a piston joint will look like. Now you see they're not going to rotate because it is forced itself to maintain this relationship, this strength relationship between them. And in the joint properties of each of the piston joints, I've checked off the enable limit box here and set an upper translation, in this case of 1.1. And what that does, if you zoom in here, you can see there's a limit at which this piston won't go beyond. So if we move the translation limit in and out, we can widen out how much influence that piston joint's going to have. So now it pulls out even further, but it won't allow itself to rotate down. Now what if we were to do spring joints? Once again, connected in the couplings here, the way that normally would, the way we did with the distance joint. Now when we run it, you see there's some spring effect on these, and that can all be adjusted tension-wise over in your joint properties as well. So by playing with the different joint systems, we can get very different looks. And there's a lot of different properties in each one of the joints that we can influence to change the relationship between the bodies. There are two new joints in the new version of Newton, Newton 3. The first of which is wheel. So I got my scene set up here, just a car body with a couple of wheels, and I have my ground. If we select here the, I call it road. It's just going to be animating along with a tree connected to it. The tree and the tree trunk are connected to the road by a parent relationship. So let's go into Newton here and zoom out here. Our car body, we want to create a wheel joint from the car body to each of these wheels. So by selecting the car and then the rear wheel, we will click the wheel joint, and that makes a connection between these two here. And do the same thing with car body and the front wheel. There you go. Now we have a joint system. And let's first make our road static, by the way, so everything doesn't drop away. Now if we were to run this as is, it collapses on itself. The reason for that is, by default, if I go back in here and select, let's go to the first frame, we'll see that the joint system creates the suspension by default along the connection line. That's just going to make it collapse on itself, which is what it just did. So we need to get into the anchor point tool and rotate that suspension in the proper rotation. So now that's going to act like proper wheel suspension between the body and the wheel. We'll do the same thing for the other joint. And there we go. Now, zoom out a bit. When we run simulation, it still collapses down, but that's because we need to adjust the strength of the suspension. So let's select both of those wheel joints, and we'll increase the suspension stiffness. So now we can see it's got some strength to it. Let's turn it up a little bit more. Let's double that to 4. Stiffen the suspension even more. There you go. Now we got some stiff suspension going. It's still rolling off. So to prevent that, the wheel system also has, we'll select the rear wheel joint system here. It also has a motor. So by clicking on enable motor and giving it some speed, let's say we'll give it a speed of, who knows, we'll try 3 right now, and we have to give it some torque, and torque is the amount of power it has to drive whatever objects it's being connected to. So let's say the torque of 30. Now when we run this, when we start the simulation, it's going to drop to the ground, but this wheel is going to start spinning and driving it forward. So there it goes. It starts to move across our environment. Now we want to take our road. If you remember, we had created keyframes in the timeline for this road to move. Let's take it from static to kinematic and run it. Now the car isn't quite keeping up, so I think we probably have to increase the speed of the wheel. I think the torque as well. It didn't look like it was struggling a little bit. So selecting the rear wheel joint, and let's turn this to speed of 4, and the torque, let's go to 50, give it more strength. Let's see what that looks like. Okay, still, it could use more speed, I think. Let's really jack this up. There it goes. Now it's keeping up. Not too badly. And there we have the car running. And of course we had the tree in place there set on dormant so that it stayed in place until the car made contact with it. Now the last of our joints is also a new one to Newton 3. We'll take a look at it, and it's called Blob. So here's a very simple setup of a floor and two objects. And these objects, actually there's several objects making a shape. Now what we're going to do is we're going to connect all of these small circle shape layers with a joint system. And we're going to use the new joint system, Blob. So if we go into Newton, first I'll select our floor, make it static. I'm going to take the gravity to 0. I'm going to select all of the first set of little balloons, as I called them, and I'm going to connect them with the last of our joints in the joint system, Blob. And it creates a new joint system relationship between each one of them. There's not a lot of controls here. It seems that the control for the Blob joint system itself is all built internally. As an example, actually I will turn on the magnitude here for a second because you might as well see what it does. I won't connect these. These will just drop away and scatter. But you'll see when I invoke gravity what the relationship between all of these objects does. It tries to maintain some sort of volume shape. It loses its initial shape but tries to keep the volume. Now if we were to select a second set over here and then give them blob joints. And then the first set, let's say we were able to select all of these and we want to give them some velocity to bump into this one. Let's turn off gravity. And with all of these selected, we'll give it a velocity magnitude of say 1. So it's going to, and if we use our velocity tool, you can see it's going to move in that direction. So when we run it, it'll bump into the other one and have an effect. And you see it will pass right through it because this does not have volume itself. Don't forget, these are just small objects being connected. Now if this object were to connect with this one, like we could actually move this over so that when it moves it will make contact with that one. And there you go. You see it pushed it until it rolled off of its surface. So you can create some interesting effects with it just on its own in this way. And you can increase the amount of shapes you have to try and give yourself a smoother effect, but you'll find that you don't need to do that because I'll show you how to connect all these lines for final render. So here we have it with those shapes rendering now. Now the makers of Newton 3 are Motion Boutique, and they've created a free script tool that is really, really handy to have. And it fits nicely in with the Newton workflow. And this is a perfect example of how it fits in. So I'll pull it open here. And it's called Connect Layers. So what we can do is let's select all of our shape layers here. You see that all these shapes have keyframes after our render. And we want to connect them so that they're just a solid line. And that's what Connect Layers will do for us. Just in the options menu, we're going to make sure that we have Auto Bezier selected. The stroke width is set to 1. Let's change that to 10 for now. We can always change it afterwards because it creates a shape layer. And the color we can always change later as well. And we want to create it as a closed rope. So the beginning will connect to the end. We say OK, and we select. We have 3 different options here. We're just going to concern ourselves today with the rope. So we select rope, it runs it through. And it connects all those shapes with a solid line and creates a brand new shape layer for us with the animation intact. The animation is still connected here, applied to the path. So let's turn off all of those circle shapes that made up that. Now when we run, we have that shape. So in the end, you can create an animation, say a cell animation sort of thing. Another use for blob, we'll look at one more example here. Let's say we've got some text, and the text is outlined the same way we did with the cells that we just worked with. This is a whole series of small circles that have been aligned along text shapes to create this sort of title. Now if we take this into Newton, now I've got two baselines here, like floors, so I'm going to select both those and make them static. I'm going to leave the gravity system the way it is, and I'm going to select each one of these letters and connect them with the blob joints. Now each individual letter is its own blob. So when we run this simulation, that's the sort of effect that we can get. So just by connecting the shapes the way I showed you and applying some effects on top of it, this is the sort of effect you can get with the blob joint system. So now you're up to speed on the advanced system inside of Newton. Check out my other videos in my channel and subscribe so you don't miss out on any releases. See you next time.